Hello, my name's Austin Walter, and the goal of my project was to build a 3D printer. A 3D printer is a machine that makes objects out of plastic by layering the plastic over and over again until you have a three-dimensional object. Now, I was originally inspired to do this in high school, where I came across a website that went over how 3D printers work. Since then, I've wanted to build one, but I haven't been able to do so due to lack of tools and resources. Now, with this grant, I have finally had enough money to fulfill my goal of building it. It's not fully done yet, but it's very, very close to being finished. Now, the way I perceive this benefiting me is eventually I want to start my own company selling and manufacturing 3D printers. I've been very interested in this for some time now and have always wanted to start my own company. My faculty mentor, Professor Credo, has been an invaluable resource in this project for both planning and understanding how to work on a large-scale project. The thing that probably most surprised me about this project was how difficult it was going to be to sit down and work on a project in a long-term scale and actually get results. Even today, I'm not fully finished working on it because of how much time and effort must go into designing and building the project, not to mention debugging it. That's all the questions I had written down.
All right. Thank you very much.
So, like, where is it at in the development phase then?
The machinery is pretty much all finished. The only thing I'm working on now is electronics, which I have all of. The last thing I mentioned was debugging. It was kind of added because that's where we are right now. We're trying to debug it, figure out why it's not working. There's some small things that aren't going the way we were expecting them to.
Like what?
Um,
I'm curious.
the motors are powered by these driver boards, which are powered by a main motherboard, which you connect to your computer. Somewhere in between the computer and the motors, the signal's getting messed up and it's not moving the motors the way it should.
Interesting. So then how are you guys even go about troubleshooting that? Like,
I've been working on that.
yeah. I work in technology and we're always, is it software-based, hardware-based, or is it user
Right.
error, and trying to categorize, okay, which one is it?
One of the things that I've been told several times is that I have a lot of layers that I'm trying to work on at the same time, and so I should reduce the number of parts. So I'm working on a really high-scale software right now, and so I'm probably going to stop using that and start trying to program it by hand to see if I even get any signals to it. And we've been individually testing the motors to see if they've even been getting signals at all.
Is this sort of a three-dimensional printer? Is it common in industry, or is this really a unique invention?
This is becoming, the 3D printer is incredibly interesting in the fact that some people have been calling it the next computer, in the sense that it's existed for a while, probably several decades, but it's been really, really expensive. And it's only started to become less expensive in the past 5 years, and is becoming less and less expensive as time goes on. So in the future, you'll probably start seeing these pop up in more and more places, because originally they were just for really large companies. Then it started becoming for schools and companies. Then it became for artists, schools, and companies. And now it's breaking into manufacturing as well, something that it hasn't been able to do So they're actually using really large 3D printers for building airplane parts. And eventually, what I'm hoping to see is that 3D printers break into the consumer market and start making electronics.
So I was wondering, like, the case uses, so you're saying, like, in education, and so this, like, in programs like yours,
Mhm.
that are being used to show and model, and I was trying to think of the uses of those in the industry. So, like, you used the example of they're building airplane parts.
Right.
Do you have other examples of how it's used? I mean, I'm just curious. Like,
Okay, so it was originally used as a rapid prototyping machine. The goal was that it would create a really cheap part that could be used on a prototype, but wouldn't be what you used for the final project because it wouldn't be as sturdy. But more and more lately, the quality has been going up so that they're starting to be able to be used for the final product. As well, it's starting to become faster and faster because before it used to take a really long time to make an object because, as you would probably think, it takes a really long time to do one layer after another, but they're finding faster and faster techniques, and they're being able to do it on a smaller and smaller scale, which is allowing it to be used for more and more things. So now it's being used for airplane parts, prototypes. There's one company that produces 3D printers that have been used by people in fashion to design bracelets and shoes. In addition to that, it can be used to make toys. So there's a website online where people can post their designs, and then other people can download them for free. So people have posted toys and like construction sets that you can download and print, and then children can play with them.
What department are you working through?
I am currently an electrical engineer working through the EECE department. I might switch to computer engineering.
Which is within the same department.
Yes, it's the same department.
So how does this relate to RepRap?
Yes, RepRap, that was the original community that I got the idea from. This is actually their design. It's an open source project that posts designs for how to build a 3D printer, which I then downloaded, and I printed these plastic parts on the school's rapid prototyping machine, and then cut the metal parts myself at the school's metalworking area.
If machines that build themselves, you can build more of themselves.
That was RepRap's goal.
It's mostly plastic, and it can create plastic parts, so in theory it can recreate itself.
Interesting.
It's interesting.
That's nice now, but you know what, Terminators could do
It's only humans, though.
Well, I can imagine, at some point, and maybe this kind of system is already in existence, but rather than having to do extensive programming for each thing that you build, that, there could be, lighting that would take a photograph of something like this.
Scan.
You're talking about 3D scanning.
Yeah, scan it, then model,
Mhm.
do the model just from that scanning.
That exists in several forms,
Oh, yeah.
which is also expensive at this point in time, but it's becoming cheaper and cheaper also. So in the future, something you might see is 3D scanners in department stores that might scan your feet to know what size you are, and then make shoes specifically for you.
Wow. Maybe eventually instant clothes.
Yes.
Well, they already have smart clothes. Have you seen these smart clothes that think for
That's scary.
themselves, that have the technology in them?
Really?
Yeah, I read a few different articles,
Oh.
even one that you could wear that charges, that you could charge all your stuff on, that charges from your body heat. Yeah, it's pretty neat.
Mhm.
Are they smart enough to wash themselves?
There are some, they have actually underwear that are smart enough to tell you when they, it was a weird
They change
article.
color.
They
But
crossed
they
on
already do
flip.
change color if they need washed.
Actually, it was on the flip board, iPad flip, in the technologies are with the new tech stuff. So it was like some smart clothes. Mhm.
I know even a few years ago, Levi's was coming out with a 3D scanner because, you know, they claim people have different body types and they can create jeans specifically for you. And you walk in this scanner and it scans your body.
Future of clothing manufacturing.
I know the military had a huge interest in that, you know, because athletes wear these, you know, nice fitting, and the military was interested in a uniform that was kind of similar to athletic wear that doesn't impinge on your movement, and, but you can still carry equipment. There's a lot of interesting applications related to what Austin's working on.
It's pretty cool.
One request, since you're going to be here in the fall,
Mhm.
I wondered if you both would be willing to be on a panel at the CELT conference, talking about undergraduate research and your project and about the process, and
Mhm.
hopefully we'll get other faculty and students there who might be interested in doing similar things.
I can't say specifically right now, but I'm definitely interested in doing it.
That'd be great.
So I'd love to talk to you more about it.
I'll let you know.
I have to double check the dates, I forget the dates, but as long as I'm free, I can be there.
That'd be great. It'd be October 17th through 19th.
Oh, okay.
And, you know, I'm not sure what the time would be, but we'd let you know and see if that was
Mhm.
workable for you. That'd be great.
Yeah.
Well, thank you very much. What an
Mhm.
Yeah,
interesting
thank you.
project.
It is.
Thank you.